to another video, and this time I want to talk about the Breeze X, or the Brixton Model X. That is a 3D printed model designed by Dr. J. Ma. I don't know the full name, but that's just the handle that he uses on MakerWorld. And it's a really an excellent designed wing, I have to say. I think it was Rock FPV that by chance found the model, and we started to print it. Both of us, we both got fairly new Bambulab 3D printers. We used to have Creality Enders. I had the Ender 3 Pro, or I still have, but I did upgrade to a Bambulab, and so this was something that was a nice project, to actually test stuff, to test especially lightweight PLA. This is Bambulab PLA Aero, it's called, but it's basically lightweight PLA. You can also print the kit or the build in lightweight ASA or something similar. I think some also printed with real with PETG or PLA. Wouldn't recommend that because I think it's getting too heavy, and it's just fine with this. The build that I've made are also basically all our 3 builds. We also made one for average FPV, and he put it together with his system. But basically all of us are around 350 grams, which is really nice, which fits well with the surfaces. And basically I just want now to share how we did it. Maybe it gives you some tips, because there are some small things that I think you need to look at first, or maybe take care of, and maybe also show this. The damage here, this was a rough landing, or let's say I was landing on a just next to a grass, and it was a way with stones, and a stone hits the wing, and basically that's normal. This happens with lightweight PLA. I think you would also have quite a good dent in foam, but not so much. You wouldn't have to fix it. And here the good thing is the way this is designed. These wings, they're held held in place by PLA parts, these green parts, these connector parts, and basically you have these pins that you can plug in, and these hold them tight together. I took these out, so now I can just pull it out. And you can also see here, this is a 30mm carbon spar that makes the whole thing rigid also. I mean, it's also in the same way rigid. The wings won't flex that much, I think, as foam or something does. And here also you can see the Servos mounted into this PLA part, but I will show you that a little bit nearer. The good thing, I basically anyway wanted to change the wings, meaning basically this part I had to print newly because the winglet is glued to it, and I wanted to try the larger ones, because I think these the plane will maybe fly even better, be more stable. It flies good. It has enough lift and everything, but I think I'll try it anyway. We'll see in a further upcoming video how it will fly, or I will maybe attach a flight if I already have done it after this video. But yeah, basically I've printed new wings. That's easy to do because one wing with settings that I use takes about 2.5 hours, I think, and winglet is maybe about 1 hour printing time. This is waste mode, and this is the thing. We come to basically the next topic, how to print it. I cannot give you the details or tell you how you should print it or how you would print it, because it's different on different printers. I've got the Bambulab P1S, so basically I could use the files that are supplied with the build. For other systems, maybe Creality or other machines, you wouldn't need to figure out what settings will fit. I guess the flow settings and stuff will be similar, but lightweight PLA, you need to, the best thing is to do some test parts, see how the flow is, and go according to some known print settings, try these out, look if they work. Yeah, and basically you just, as I said, you print the wings in vase mode, and you also print the winglets in vase mode, and a very good resource for printing planes for the settings and everything. And we also found, we also found our settings there was Soarcraft. It's I think a guy that builds or that designs and builds sailplanes, and he has very good settings for all kinds of machines, and he says also the material that you use for printing is quite similar, so you can use these settings just to start with, look if it works. I will also link the site and the link to these settings below, because what we did is something that I want to show you here. If you look at this here, this edge here, some had some issues when they I don't know if it focuses, but some had some issues that when they printed this, they had due to everything being pulled out of apart, you had kind of like holes in it. And if you use the Soarcraft settings with waste mode, then it works fine. So basically this is perfectly fine. Also very light, as you can see, because it's just one layer that you print with the material, and he's a little bit, I think, on the hotter side, and with a little bit different flow settings. I think it's about 250 degrees that he uses, but it really works well. So I recommend to try both. You know, just do maybe small test files. There are, Soarcraft has got one test wing part that is just a snippet of a wing. If you can print that, then you can go on and do the other stuff. Yeah, and basically the model is made out of, for me it's 3 materials that I'm using. It's lightweight PLA or PLA Aero, and you also have these parts, the accessory parts. These are printed out of PLA, very important parts. And also here you can see the design, which is really awesome. These are the parts that hold the wings together, and this is the part where basically that's I need to have the right wing that is attached here to the wing that you glue into this. It's really nicely done. Will hold the servo, you screen the servo, and then when you put it together, basically you have this part which is glued to the body on the side, and this will match exactly. You see here with these, it will match flush in, and if it's inside, then you can just plug in these PLA pieces, and they hold the wings very tight, which is really awesome design. I think there seems to be more thoughts gone into this wing than some other fixed or finished builds, and here it really saw done a lot of features, done good stuff. Also 2 versions of winglets. We also all printed the shorter ones. Afterwards we read, hey, it should be flying, or it will be flying more stable with these, so I'm trying these. But back to the wing itself, just to show you some things that you should think about first. I would recommend, if you, the most of you will basically be building this for FPV, I guess, because of course there's an FPV channel, and that's also what we wanted. The wings, or the description says 250 grams, and that's basically not achievable with FPV gear. Even so, I've used a light 1S board and everything. It doesn't matter, because basically the wing is maybe 250 grams if you just use a receiver, a small one, the ESC, and just a motor, just this. And everything that you add on is plus weight. So, but it's fine. 350 grams is fine. And what I wanted to show you now is the parts that I do not print with PLA or PLA Aero. And that's, I'm using PETG, and I'll tell you also the reason. And this is here, the canopy which is holding the camera. I'm using, by the way, V2 HT Walksnail camera, because of the gyro that's built in. I flew the first pack without a gyro, without stabilization of the cam, and yeah, of course, it's a small wing and it will have a lot of vibrations, or it will shake in the wind together with vibrations. Also, what I also printed in PETG is the motor mount. And by the way, there are more than one motor mounts, there are different ones. Here's the one, sorry, I hope this focuses, which is going slightly up, so the motor will be up and it has the right angle. The thing is, if you print the original one, that is here the low one that I've got, you need to screw the motor onto the mount before you put it into the plane, before you glue it into the plane, because as you can see here, you cannot get to these screws anymore. So basically this is fixed in, but I did that on purpose. My friends basically used this one. This is a little bit higher, so the motor is up, so you could remove it again, but I didn't like that the motor was above. I wanted to have it, you know, really in the axis, just to see if it makes any difference. I guess not, I guess it works, but just so you know, if you're in doubt, you want to change the motor, then use this one, because you will be able to screw it off. Also use the right amount of infill for these. I think it should be full, just because it's PETG. I'm using PETG because PETG has maybe, I think it goes up to 71 degrees until it gets soft. So if you have a motor that will get warm, it shouldn't happen, but if it happens, then there's a little bit of leeway. With PLA, if you use the PLA material, it's only 55 degrees, so it'll get soft pretty quickly as soon as it's getting a little bit warm. That's why I'm using this. And also it should be a little bit harder. It's more brittle, PETG, but it should be harder. So yeah, I've made these. Also camera mounts, I'll print them out of PETG, not PLA, because I think it's a better material for this. Oh, I forgot, I've got a small part underneath the VTX that's made out of TPU, and that is just, by the way, with Titan screws from another build, just to make it light. But I'm using that as a, you know, it's like a piece in between, so the heat from the VTX can never get to the PLA material. Even so, it doesn't get any warm, you know, when you're flying this. Anyway, it's a 123S VTX, and they're quite good with heat management. Even if you fly with 500 milliwatt, it doesn't get warm basically, and there's more than enough cooling here. But just to be sure, that's something that you need to think about with motor mount. For motorization, that's actually something that I've seen, or that I feel. I'm using a 1504.5 Brotherhood 3950 kV motor, so kind of hot. It's a 4S motor for a quad, for a 3.5 inch. And I used this. I tested it first with a 3.5 inch prop with 2.5 pitch. It flies really good. It has more than enough. How do you call it? The RPMs. I think they recommend actually to use. What was it? Let me check in the build. They actually recommend to use a 1406 3300 kV motor. If I look at it, kind of makes sense, because with almost 4000 kV on the higher band, you can notice that the plane will start to kind of vibrate from the high RPMs, because these, I think they are not quite in the motor and the prop are not so really balanced. We could maybe try to balance them, would maybe also help, but I will try that later on. But the high RPM, you see in the picture, you get these micro vibrations, and with 3300 kV you won't have that much at that high RPM, so that would certainly work. But what I think is they recommend, or he recommends a 3-inch prop with I think 5 pitch, high pitch. Okay, I would go for a larger prop, maybe. because this is a 3.6 inch and this is a 3.5 that I used. The new one is 3.6 inch with 3 pitch. I think it makes more sense to use a 3 or 4 inch, just a larger prop that can spin slower, and it's more than fast enough to fly for this model. I guess if you would go full speed also with this, I cannot, it's just an estimation, it goes over 100 kilometers per hour, that I'm pretty sure. And this should be even faster, but I put this not for flying faster, but to to have enough punch at also at low throttle. By the way, the model does really fly very, very economic, so you can have a flight time of about maybe 10 minutes easily, with really hooning around with a 3S 1300 LiPo. And that's the next point that I'm coming to, which my recommendations is, as you see here, the cables. The cables, these are all quite thin cables, and I'm using XT30 connectors. These XT30 connectors are lighter than XT60. Most of the systems come with XT60 for planes and for stuff, and to be honest, it's just overkill, because with one motor, even if you go in full speed, you don't pull that much amps. It's not like a quad where you have 4 motors pulling and you go full speed. The cables will never get warm, and the connector, you don't. You're flying 10 minutes, so you can easily use just AWG18 cables, which makes the whole thing lighter. And also it's much easier to get stuff in and to bend the cables. If they're large cables, then it's just coming in the way, and it's harder to actually to fit everything in and have the lids closed on top. Yeah. One thing regarding flight controller, I'm using the SpeedyBee Mini 405 or 405 Mini for wings. And if you have the servo connectors here, it's basically, it will push onto, it's really a little bit too high, and it's pushing on the lid, so the lid will not close, or closes very snugly. So for this bit, I normally do not recommend to solder them on, but if once you're good, you can basically solder the servos and the other stuff, the RX, and also maybe the ESC if you want to. Then it will fit flush in, or you use a smaller like Maytech 405 WMN FC, which is not that high, so that will fit in perfectly. But it works like that. And also regarding CG, it's basically really easy to get the CG correct. There are marks here below, and it's all even written in CG. So basically you put the battery in. I've got a sticky pad here, so if I put the battery in, it will hold and it won't move if anyone move forward or so. Just my recommendation: use this pad that he recommends to glue it in, and put a I think, what are they called, Umagod light or something like that. Or if you want also some of these what are they called, these straps that are Velcro, exactly. I'm sorry, Velcro. Velcro is a little bit higher. So the thing is, I started with these batteries. These are 60C from the same manufacturer, Swiss manufacturer here. Now I'm using 35C. Why I'm using 35C doesn't matter at all, basically. And they're actually cheaper, and 35C is more than enough for this plane. You won't pull a lot of amps. And these are only 21 millimeters thick, and these are, I think, 23 millimeters thick. Let me quickly check that I'm not lying here, because that's yeah, exactly, that's an important fact. Because 21 will fit in perfectly. If you also with Velcro, it should be fit in snug, and the 23 that I used in the beginning, these are just slightly too thick, and you won't be able to fit any Velcro below, or it will push up the lid. You can't close the compartment. So look out that you use 21mm thick lipos and nothing thicker than that. Like I said, I really recommend using lipos because 3S 1300. I mean, somebody can fly longer than 10 minutes and not get bored. All good. Or if you want to go far, use these some lithium packs and not these lipo. But I mean, this is more than enough if you're beginning just to try, and they're much cheaper. They're only maybe $20, $15 or less. So it's an economic to use. Okay. So I quickly got to look up what the next topic is that I wanted to talk about. Okay, all the parts, if you print the whole plane, it takes maybe a little bit more than 10 hours or less with a Bambulab. Depends on the printer, but I think Lightweight PLA or other things, you won't be faster than with other printers. It's more how you print, maybe on some certain parts if you have a printer with input shaping and stuff, so it doesn't matter. It should take about around 10 to or maybe more hours, but that's very fast for a plane, which means if you have something happen like me here, where you damage a wing and you need to replace it, that's easy to do. You basically just print the other stuff, you take out the servo here, just gluing this part here, the servo horn, and you put it into the next wing. Off you go. I'm putting now the two new wings in, and I'll be ready to go again. So something that I wanted to mention also, because somebody asked me how to build it. It's basically for me it's straightforward. Just look at the drawings that he's got on Maker Walls, on the link. Basically it shows all the parts, but just keep in mind when you start, don't glue in the motor mount, don't glue in stuff just before you've or just test fit it, put it on, see if everything's flush, if it works, and if you're okay with it, then you can start gluing. Otherwise you will have to print certain parts more than once. Happened to us. So yeah, there's also another option for the cam. You can print the front with a cam coming out here, which Average did. Also looks nice, and you can put everything inside if that fits. The thing is you just need enough airflow, so I would recommend, if you do that, maybe that you design a small hood scoop or something to push in air behind the battery, because the battery will basically block the airflow even if it's open here. So make a small scoop here upstairs where I've got my cam, if you use it here, just to get in air into to the VTX. And also you just need to think of where to place your stuff, but there's not. You can do it as you like. Also, I've glued my ERS antenna here on the top. Works good. Yeah. Otherwise, what I wanted to say is regarding gluing. I think that's something that people have asked. Just you put the parts, line them up first. Look if they fit. Because some of the parts you will have to maybe cut a little bit of the material just to have it fit, because there's some leftover print or something. But as you can see here, I have to align it first. It fits really well, tight. See here? And if it fits like this, you see it. Okay, yeah, it's really nice. Then take it apart. Use CA glue. I'm using this normal Slap a Gap, but you can should you be able to use any CA. Put it on, and there are some parts that you need to open up, to cut out. These are these parts here. They're these holes. I hope you can see it in the camera, but that's all marked on the plan. Just look at the plan. And here also this part where the servo goes through and looks out, the servo horn. You need to just take a knife with an X-Acto, just show you, and you know, go like this, cut it like this open. Then there's also a very nice. These are PLA parts. These will make the leading edge more stable or sturdier. So basically, what you do is also test fit. Test fit these parts by pushing them in, just to see if they match, if they fit. This doesn't seem to fit that well here, but that's why we're trying. As you can see now, it works. Yeah, it would work. So as soon as you've put it in, don't push it full in, because you will maybe have a hard time getting it out. But I know this should work like this. I'm taking it out again, then apply CA glue just to the top part, and then push it back in and see that it's fit fully, that it's fit in the wing. That's it, basically. The same with these parts. Once you know the wing has these square parts for the servos, fit them in and glue them in with CA, so that fits perfectly. That's basically all. The side parts also, these are very nicely done. If you look at these parts here, they fit very snug. Just first check, that's always to, if it fits without glue. If it's like this, perfect. Don't glue this before you actually build the wing and stuff, because if you put this in, then it'll be hard to fiddle around on the table with the winglet on. So you can put the winglets on at the end. That's the best way. One thing that is maybe a little bit challenging is this part here, the surface, because you need to cut it. And I tried to show here. It's basically all the way through. It's a V, and what you try to do is you basically try to cut it as near as possible to the wing itself. And this needs more than one go. You just go through, cut it carefully, and then you take it apart, separate it. And what you then need to do is, I recommend using CA hinges. I will show this on the side here, or also post a link to them. You take CA hinges. They don't need to be the right size, or I mean these small. You need to cut them, and you basically cut 3 of them to the same size that the small parts you get that are out of PLA, or that they recommend to use, made out of TPU, and then you put them onto one side. Let's say first the surface. Because there's also how do you call it, a slight gap here where you can fit them in, as in the plan. You glue them in. Look that they're basically nicely lined up on three ends. Glue them in, and then you basically let that set. Once it's set, you take the wing. You look if it fits nicely, and then also move it to see. It shouldn't be flush, you shouldn't push it back, because you won't be able to move the surface nicely then. So you have to have a little bit of a gap in between, but then you can see that if you move it, how much of a gap it should be. Once that's that's made and set, you put glue on it, push it in, let it dry with the gap nicely, and that's it. Then basically the wing, you only need to glue on these not servo horns, these horns here. There's a marking here, should fit fine, but what you need to do, and that's important, align them to the servo, align them to that it's flush in a line, because you will need the wires, or the steering linkage, that should be in a line, because otherwise it's pushing here against this horn if it's not nicely done. And then you also use CA glue this on top, and that's then basically what we have here. What you can see here, these are some parts that you need to basically get That's I think it's 1 millimeter of wire that I'm using, and I also use the wire bending tool. I've also linked that. That would be a, a video itself. The wire bending tool. It's just to get such C parts, such a C to use in the servo horn. By the way, these servo horns come with the servos if you order them. If you order a servo, you should just get some, and these are the ones that I use. These are too high. I could cut them, but I just wanted to leave them first to see how if I need more travel or anything, but it's fine like that. I could cut them later on. It would be easier then to get the servo out and stuff. And on this side, you can do it as you like. There are more than one. There's more than one method for this. I'm just using these end stops here that you can screw into the horn, and also in here fix the length once the surface is flat. Basically what you, most important basically also, I forgot, but I think that is clear with any build. Before you put screw in the servo, you make sure that the servo is straight, that it's not straight, I wanted to say neutral, in a neutral position. Basically you turn on the radio, have your FC and everything set, the correct mixer set, and then it should be at neutral, and then you put on the servo horn on the same position on both sides, that it's straight. Basically what you're trying to do is have this and this, these both lines should be parallel to each other, and the surface should then be flat. That's what you're going for. Then it should be at neutral, and then you won't have to adjust much anymore. That's the goal, and it's also the travels then are linear, so that's the best way to set up such a model. Yeah, I hope that summed basically the build of the whole thing up. Also a little bit of troubleshooting or tips, how to build it. I think it's already quite long, the video, so I stop rambling, or I will think about if I have everything that I wanted to say that should help you build this plane. Like pick the right motor combo. I think a setup from a 3-inch or a 3.5-inch quad also fits this. So if you pick a heavier motor, then you will have to put more weight in front, and keep in mind the motor is quite far back, so that can have an impact. But with let's say anything between 1404, I guess, to 1506, or even a 1507 should actually work, because you've got enough space also here to push the quite heavy battery back. Yeah, and you can also play with the VTX to put everything a little bit more in front. But first, before you mount everything in, look how the CG is, that you can then, that you don't have to adjust a lot with battery or stuff. Yeah, I think that's basically it. That's how we built our 3D printed wings, and I'll show you some footage also from my last flights. I mounted the prop the wrong way. I mean, not that it's going backwards, but with the sharp edge to the wrong way. That means that the prop wasn't efficient, and I think I had maybe about 30% of the power that it normally has. But it was just good, for testing and checking the stability that I get with the gyro and with this cam. Thanks for watching. Have fun if you build this. It's a lot of fun. I really like it, and I'm happy to fly more and also test the new larger winglets. We'll drop a video on this. So thank you very much. Have a great day. Bye bye.